Stack. A stack is a linear data structure that follows the LIFO principle. What is LIFO principle? LIFO means last in, first out. So think about any stack that you know, that you generally see in your daily life. It will always follow LIFO principle. Let us say a stack of plates. How do you stack plates one over the other? You'll have one plate at the bottom. Over that, you'll keep the next plate. The next plate is kept over that, next one over that, and so on. So you'll keep putting plates one after the other on top of the previous one. So what is the speciality of this? Whenever you want to take one plate out, how will you take out? You have to take out the top plate. This is what you have to take out. What happens if you take out the bottom one? All the other plates will fall off. So the only option you have is to take the plate on top. So now think back. Whichever plate came back last is the one which is going out first. So that is why it is called a last in, first out data structure. Whichever element comes in first will stay there. Whichever comes in last will go out first. That is stack. So why are we discussing about this special data structure called stack? The main thing is that previously we learned about some data structures, arrays, linked lists, and so on. So when we learned about arrays, we saw that there were some operations which took order of 1 time. There were some operations which took order of n time. And what about linked list? The same. There were some operations which took order of 1 time, some operations which took order of n time. But coming to stacks, every single primary operation will be done in order of 1 time and order of 1 space. This is the speciality of stack data structure. You take any of the primary operations on stack, you can always do it in order of 1 time. So you can do all stack operations in order of 1 time. It is time effective, cost effective. That is why you're discussing about stack. So let us see how you can implement stack. What are the primary operations in stack? Let's discuss about primary operations first. So there are 5 primary operations on stack. The first one is the push operation. Push operation. What is push? Pushing is the process of inserting an element into the stack. Let us say this is your stack. You want to insert an element into the stack. 1 element, 2 element, 3 element. Whenever you want to insert, you use push operation. The second one is pop operation. What is pop? Pop is used to take an element out of the stack. Let us say you have these elements. You want to take one element out of the stack. Then you use pop. And third one is peek operation. Peek. What is peek? Peeking is looking at the top element of the stack. So you're not disturbing the stack. You are not inserting anything. You are not taking anything off. Instead, you are simply looking on top of the stack and seeing which is the top element. So this is what you call as peek. Some people also call it as top operation. Both are the same, peek or top. The fourth operation is empty operation. This is used in order to see whether stack is empty or does it have some elements. So this check is what you call as empty operation. And the fifth one is full operation. Full operation, this is used to check if the stack is already full. So these are the 5 primary operations on stack. And what is the main point? That every single of this operation can be done in order of 1 time and order of 1 space. So this is the speciality. The next thing is, if you want to do something like this, how do you implement a stack? You want to do it in order of 1 time, order of 1 space. How do you implement these operations using a stack? You have 2 options. The first option is to use an array that we already learned. Another option is to use linked list. So when do you use array? When do you use linked list? This you need to know about. So one thing is, irrespective of whether you use array or you use linked list, you should be able to do all these in order of 1 time. So how do you actually implement so that all the operations are in order of 1? This is what we learn in the coming lectures. So keep just one thing in mind. Because you want to do in order of 1 time, you have to keep in mind that you should always maintain direct access, and secondly, you should have efficient pointer manipulation. So how do you do this in arrays? How do you do this in linked list? And how do you get stack implemented? That is what we are going to look at.